In this video, we will learn about concept of differential equation. What is differential equation? What is order? What is degree of differential equation? And then we will start solving exercise 8.1 from M.L.Aggarwal Applied Mathematics class 12th. So let's start. So before starting, what is differential equation? We already know how to differentiate a function. For example, y is equal to x squared. So if I differentiate it, what do we get? Dy upon dx is equal to 2x. So if I take 2x to the left hand side, dy upon dx minus 2x is equal to 0. So this is the differential equation. This is a form of differential equation. So differential equation is an equation which involves independent variable, dependent variable and derivative of dependent variable with respect to independent variable. So what is order and what is degree? These are the two basic concepts of differential equation. So let's learn about order first. The order of a differential equation is the order of highest order derivative appearing in the equation. So what is highest order derivative? Let's understand this with help of this example. Dy upon dx is equal to dx. So this is first order derivative. First order derivative. We can also write it like this, y prime or y sub 1. If I differentiate it once again, what do we get? We get 2. So this is second order derivative. Second order derivative, or we can also write it like this, y double prime or y2 and so on. Differentiating it once again, we will get 0 because derivative of 2 is equal to 0. So this is third order derivative or y triple prime. So these are the first order, second order, third derivative and so on. We can go on. So what is order of the differential equation? This is the order of differential equation is the order of highest order derivative in a differential equation. For example, let's take consider this equation. For example, d cube y upon dx cube plus dy upon dx square plus 3x is equal to 0. Suppose this is the differential equation. So highest order derivative is what? This is the third order derivative. This is the first order derivative. So highest order derivative in this equation is of third order. So order of this differential equation will be 3. It's so simple. We just have to find the order of the highest order derivative in a differential equation. So let's take another example. For example, dy upon dx raised to 5 plus d square y upon dx square minus 3xy is equal to 0. Say. So this is first order derivative. This is second order derivative. So order of the highest order derivative is 2. So order of this differential equation will be 2. Now degree of the differential equation. So what is the degree? Degree is the highest power of the highest order derivative involved in a differential equation. Highest power of the highest order derivative. For example, in this equation, highest order derivative is of 2 second order and its power is 1. If power is not has not been given, we just imply that it is 1. So degree in this case will be 1. In this example, third order derivative is of highest order and its degree is and its power is 1. So degree in this case will also be 1. But this is not so easy because there is a condition here. For the degree of a differential equation to be defined, all the terms involving derivative must be in polynomial form. So what is polynomial form? That means that all the terms involving derivative should be free from sine function, log function, cos function, radical sign, fractions, negative powers, and e which has a constant value, but there is a reason for it. I will explain it in another video maybe. So so all these term involving derivative should be free from all these, then the degree will be defined. For example, dy upon dx plus sine dy upon dx is equal to 0. Take this example. Now in this example, order is 1 because first order derivative has been given here and here. But degree is not defined because sine function has been given with the derivative. So this term involves differential equation, and this does include sine function in it. And so degree is not defined here. Another example, suppose dy upon dx minus 3 d square y upon dx square plus log y is equal to 5x. Now in this equation, this is first order derivative, this is second order derivative. So highest order derivative is of second order, so order will be 2 of this differential equation. And what is the degree? This term involves derivative, this term involves derivative, and both these terms are in polynomial form. So degree will be defined, and this is the highest order derivative, its power is 1, so degree will be 1. Remember, log has been given with y here, and this term does not include any derivative, so degree will be defined here. So order will be 2 and degree will be 1. Sometimes uh, uh, a differential equation, in a differential equation, the terms that involve derivatives are not free from radical signs or fractions. So sometimes we have to get rid of these things. We can get rid of these things, and we can change our equation into a polynomial form, and so that we can get our degree. So that degree is defined. Let's discuss it with the examples. Let's discuss it with this example. Consider this equation dy upon dx squared is equal to y dq by dx cube. So this equation, this term involves derivative, this term also involves derivative, but order is 3 here because clearly highest order derivative is of third order, so order will be 3 of differential equation. And what will be the degree? Now this term involves radical sign, square root sign, so we can convert this into polynomial form. How? Squaring both sides. By squaring both sides, if I square left hand side and right hand side, 1 plus dy upon dx whole square and squared y squared, right hand side will also be squared. Okay, so 2 will be cancelled with square root sign. So this gives us polynomial form of the terms involving derivatives. So d cube y upon dx cube squared. So in this case, degree will be 2 because power of this highest order derivative, which is of third order, is 2. So degree will be 2. So without wasting a second, let's now start exercise 8.1 from M.L.Aggarwal, Applied Mathematics. We will solve each and every sum here with full explanation. So first sum is y prime plus y is equal to e raised to x. Y prime, as I told you before, y prime means order first order derivative. So order will be 1 here. Okay, order will be 1 here, and degree will also be 1 because this term only involves derivative and this is in polynomial form, so degree is defined and its power is 1, so degree will be 1. Although e raised to x has been given here, and I told you that all the terms involving derivative should be free from e, but this term doesn't involve any derivative, so we will not consider this part. So degree will be defined and degree will be 1. So second part of first question, d square y upon dx square is equal to 3xy plus x squared. So second order derivative is of the highest order here. So order will be 2. And what will be the degree? This term is in polynomial form. So degree is defined at, and it will be 1 because power is 1. The second sum, first example. Second sum and first part, x squared y minus 3x dy plus x cube minus 3y squared dx is equal to 0. So x squared y minus 3x dy is equal to minus, we'll take this expression to the right hand side, 3y squared dx. So taking dx to this side we get dy upon dx, and taking this to this side we get minus x cube minus 3y squared upon x squared y minus 3x. So this is of first order derivative, so order will be 1 and degree will also be 1 because this is free from any obstacles. We can say this is in polynomial form, so degree will also be 1. So second part of second question, it is the question is 1 minus y squared dx plus 1 minus x squared dy is equal to 0. So 1 minus dx. So taking this here, dy upon dx is equal to 1 minus y squared upon 1 minus x squared. So order of the differential equation is 1. First order derivative is given, so order will be 1. And degree has not been given, we will imply that degree is 1 because power will be 1, so degree will also be 1. Third question, first part, 1 upon x d square y dx square plus 5x dy upon dx is equal to 2x. So in this case, second order derivative and this is first order derivative, so order will be 2. Highest order derivative is of second order, so order will be 2 and degree will be 1 because power we will imply that it's 1, so degree will be 1. Second part of third question, dy upon dx raised to 4 plus 3y d square y dx square is equal to 0. So in this case, this is first order derivative, this is second order derivative. Highest order derivative is of second order, so order will be 2 and degree. This is in polynomial form, this is also in polynomial form. So degree, power is 1 here, so degree will be 1. Fourth question. Y prime squared plus y squared minus 1 is equal to 0. So y prime, that means first order derivative, so order will be 1, and degree, this is in polynomial form, so degree will be defined and it will be 1. No, it will be 2, sorry, because power is 2 here, so degree will be 2. Second, this was the first part. So second part of fourth question. Second part is y double prime plus 5x y prime squared minus 6y is equal to log x. So this is second order derivative, this is first order derivative. So highest order derivative is of second order, so order of the differential equation will be 2. And degree, this is in polynomial form, this is also in polynomial form, so degree will be power of highest order derivative, so it will be 1. Fifth question. D square y upon dx squared raised to 3 plus d squared y upon dx squared is plus log dy upon dx is equal to 2x. So in this question, this is second order derivative, this is also second order derivative, this is first order derivative. So order will be 2 because highest order is of second order derivative. And what will be the degree? This term is in polynomial form, this term also in polynomial form, but this term is not in polynomial form because log function has been given here. So degree will be not defined. So degree is not defined here. Second question, second part of fifth question. D square y upon dx squared cubed plus 2y dy upon dx plus 2x is equal to 5x to the 2/3 plus log x. So order, second order derivative, first order derivative, and both these are in polynomial form. So order will be 2 because second order derivative is of highest order here, and degree will be 3. Degree will be 3. Sixth question, first part, x d square y upon dx squared is equal to 1 plus dy upon dx squared raised to 4. So in this equation, this is second order derivative, this is first order derivative. So okay, did I miss something? No. So order will be 2 because second order derivative is of highest order derivative here, and degree, this is also in polynomial form, this is also in polynomial form, so degree will be 1. Degree will be 1 here. So 2 and 1. Second part of sixth question. D Actually, I was confusing second part with first part. Dx raised to the 4 whole squared is equal to x plus dy upon dx squared raised to 3. So in this case, this is fourth order derivative in polynomial form. This is first order derivative in polynomial form. So order will be 4 and degree will be defined because both of these terms are in polynomial form, and degree will be 2 because power of highest order derivative is 2. So 4 and 2. Seventh question. 3x dy upon dx plus 5 upon dy upon dx is equal to y cubed. Now this is first order derivative polynomial form. This is first order derivative, but this power is minus 1. So we will first have to simplify it. Take the LCM. LCM will be dy upon dx. So you know the remaining part how to do it. 3x dy upon dx whole square plus 5 is equal to y cube. So this implies 3x dy upon dx whole square plus 5 is equal to y cube, taking it to the right hand side, dy upon dx. So order will be, now this is in polynomial form, both term, order will be 1. This is first order derivative, so order will be 1. And what will be the degree? Degree will be 2 because highest degree of the highest order derivative. So degree will be 2. Eighth question. Okay. Seventh question and second part. Second part of seventh question. Y is equal to x dy upon dx plus a square root 1 plus dy upon dx square. So seventh question. So this term is also in polynomial form. This term is not in polynomial form, and this term involves derivative. So first we will have to convert this into polynomial form. So y minus x dy upon dx, taking this term to the left hand side, and a 1 plus dy upon dx whole square. So if we square both sides, squaring both sides, y minus x dy upon dx squared and a squared 1 plus dy upon dx squared and whole square, 2 and square root will be cancelled. So here this equation, this expression is in a minus b squared form. So a squared plus b squared minus 2ab. So a will be y. So y squared plus b will be x dy dx dy upon dx. So b squared, that means x squared dy upon dx squared minus 2ab. So minus 2, a will be y and b will be x dy upon dx. Now on the right hand side, a squared 1 plus dy upon dx whole square. So now this term is in polynomial form, this is also in polynomial form, and this is also in polynomial form. So first of all, order and degree will be defined, and order will be first order derivative, first order derivative, order derivative. So order will be 1. And, but there's another thing. huh. So degree will be highest power of the highest order derivative. So highest power is 2 here, so degree will be 2. Question number 8, first part. 1 plus dy upon dx whole squared is equal to 3x minus dy upon dx. Now this term is in polynomial, but this term is not. So squaring both sides first. Squaring both sides. Remember, we can find out the derivative even if the degree is not defined. And even if we can't change the term involving derivative into polynomial form. Order in this expression, in this equation will be 1. But let's solve it first now. Squaring both sides, 1 plus dy upon dx whole squared. And square 2 and square root will be cancelled. So 3x minus dy upon dx squared. So on the left hand side we get 1 plus dy upon dx squared, and on right hand side a minus b squared. So a squared plus b squared minus 2ab. So 3x will be a square means 3x squared, 9x squared plus b squared means dy upon dx whole squared minus 2ab. So 2 into a into b. Okay. This and this will get cancelled. So now order is 1 because first order derivative is here, and degree power is also 1, so degree will be 1. Second part of 8th question. 5 d square y upon dx squared is equal to 1 plus dy upon dx squared raised to 1/4. So now on both sides we can multiply the powers by 4. On both sides we can multiply the powers by 4. 4 and 4 will get cancelled. So what do we get here? 4 raised to the 4. 5 raised to the 4 will be 625, and d square y upon dx squared raised to the 4. And here on the right hand side 1 plus dy upon dx squared. Now this is second order derivative, this is first order derivative. So order will be 2. Order will be 2, and degree will be highest power of the highest order derivative. So power is 4 here, so degree will be 4. So ninth question, first part. Ninth question, part 1. Y triple prime squared plus y double prime raised to 3 plus y prime raised to 4 plus y raised to 5 is equal to 0. So third order derivative, second order derivative, first order derivative, and this is a single y raised to 5. So third order derivative is of highest order, so order will be 3, and degree, its power is 2, so degree will be 2. Very simple question. Second part, 1 minus y prime squared 3 by 2 is equal to k y double prime. So in this situation we will square both sides, left hand side and right hand side. So 1 minus y prime squared 3 by 2 . into 2 and k squared and y prime squared. So 2 and 2 will get cancelled. On left hand side we will get 1 minus y prime squared raised to 3, and on right hand side k squared y double prime squared. So in this case order will be, this is first order derivative, this is second order derivative. So order will be 2. Order will be 2 and its power is 2. So degree will also be 2. 10th question. 10th question is dy upon dx raised to 5 plus 3xy d square y upon dx squared, no, this is d cube raised to 2 plus y d square y upon dx squared raised to 4 is equal to 0. So order will be, all these terms are in polynomial form. This is first order, this is third order, and this is second order. So order is 3 and degree is 2 because power of third order derivative is 2. And they are saying to calculate the sum of order and degree. So sum of order and degree will be 5. Last question, 11th question. X d square y upon dx square raised to 2 plus dy upon dx squared plus y squared is equal to 0. So this term is in polynomial, this is also in polynomial form. This is second order derivative, this is first order derivative. Highest order derivative is of second order. So order of the differential equation will be 2 and degree will be 2 because power is 2. So degree will be 2. So product of order and degree will be 2 into 2, 4. So this will be the final answer. So with this video we complete the chapter number, exercise number 8.1 of differential equation M.L.Aggarwal applied mathematics. In next video we will learn about solution of differential equation, what is that, and solve exercise 8.2 of applied mathematics M.L.Aggarwal. So thank you and all the best.